Hello, everyone. So for today, we will be discussing amines. So this is chapter 16 of your Bettelheim book. So this is about an organic compound with carbon to nitrogen bonding. So first, we delve into the structure and classification of our amines. So we must know that our amines have primary, secondary, and tertiary, depending on the number of carbon groups bonded to the nitrogen. So if you can remember, let me expand my screen. If you can remember, nitrogen can have three bonds, no? And nitrogen also, when bonding with organic groups, have two electrons, unpaired electron. So, or two pairs, sorry. Or sorry, one pair. One pair of unshared electron or two electron that is unshared at the top of it. So, it can bond up to um, two bonding to carbon or nitrogen or hydrogen or any available organic compounds near it. So, say for example, these primary amines, the nitrogen here, if you will notice, it has one bond. Okay, it has single bond to a carbon, and carbon is bonded to three hydrogen group. More to it, no, this hydrogen is bonded to another hydrogen groups, two hydrogen groups, which is not counted. We're counting the number of carbon attached to the nitrogen directly. So that's why we call this a primary amines. This one, the second example, is a nitrogen with two carbon group bonded to it. No, so remember that when you see this type of structure, CH3, your nitrogen is directly bonded to your carbon instead of your hydrogen. You might get confused because the molecule or the atom next to your nitrogen is your hydrogen, but it is directly connected to your carbon here, right here. So this is dimethylamine. And this is a secondary amine because again, it is bonded to two carbons and one hydrogen. The third example is a nitrogen bonded to three carbons. So in this example, the unpaired or unshared electron pair is not seen at the top, bottom, but it is there, no? Hindi lang siya pinapakita dito or hindi lang siya nilalagay because it is understood that nitrogen has two unshared electron at the top of it or at the bottom of it, and it can bond up to three bonds. So we have aliphatic amines and we have aromatic amine. When you see aliphatic, it doesn't have an aromatic group to it. So it is usually linear or with branches. So aliphatic amines or all carbon bonded to nitrogen are derived from alkyl group. If you can remember, alkyl group is a continuous bonds of carbon to carbon compounds, no? When we say alkyl, there's no specific number of carbon indicated on this one, no? Unless we state that it is methyl or ethyl or propyl, no? We'll go back to our nomenclature of your alkyl or alkenes, and alkynes. So when we say alkyl, it doesn't indicate how many carbon to carbon group. Instead, it just say that we have in aliphatic amines, we have a carbon to carbon bond to it. So this time it is aliphatic amine, which means that your carbon to carbon groups are bonded to your nitrogen. We also have your aromatic amines, which is one or more of the group bonded to nitrogen or aryl group. When we say aryl, it is a benzene or it is a ring with instead of hydrogen at this point, the hydrogen here is removed and then combined with a nitrogen. So if you can remember, the formula for benzene is C6H6, which means in this part, this is an aryl because, sorry, it is C6H5 only. One hydrogen is removed, enable for a nitrogen to be bonded to its ring. So this one has common names, which is aniline. No? When we say common names, it is a name that existed before the IUPAC name or IUPAC nomenclature naming exists. So it is this one, this molecule, a benzene with an NH2, sorry. An NH2 is called an aniline. And as you may notice, this is a nitrogen bonded to one carbon atom right here and two hydrogen. So this is just a primary aromatic amines. Okay? This one, N-methyl aniline, this one also is a common name. This is a secondary aromatic amine. Okay, so where is the aniline here? The aniline here is this one, the base compound, which is a benzene ring with a nitrogen, attached to another methyl. So as you may see, this is a mixture, no, of your common naming and your IUPAC naming, which is a methyl right here, and N meaning it is linear, and an aniline group, which is the base common name of this compound. Okay, so this one is secondary aromatic amines. Why? Because nitrogen here is bonded to two carbon near your benzene ring and the other one on your methyl. So this is a secondary aromatic amine. So this one is a tertiary aliphatic amines. Um, why it is a tertiary? I think this should be okay. This can also be considered an aromatic amine since it has a benzene. Sorry. This is correct, no? This is an aliphatic amine. Why? Because the benzene ring is not directly associated with your nitrogen. Instead, there are three carbon groups. No? There are three carbon groups bonded to your nitrogen. And your carbon right here on your benzene ring is not directly connected to your nitrogen. So that's why it's an aliphatic, not aromatic amines. And it is tertiary because there are three carbons attached to your nitrogen. Now, we move on to other classification and structure of your amines. We have heterocyclic amine, which is an amines in which the nitrogen atom is part of the ring. And we have heterocyclic aliphatic amines, which is a heterocyclic amines in which the ring is saturated. No meaning of saturation, no, it has no double bonds attached to it. Okay, and we have heterocyclic aromatic amines, which is usually kapag may mga double bonds, that is your unsaturated. Tama? If we will use this in the future, no, I think you will use this in the future in your biochemistry, in which there is a PUFAS and MUFAS. I don't know if we have discussed that before, but you will encounter that in your biochem, no, indicating the saturated and unsaturated lipids. So for this one, this is saturated, which means that there's no double bond, and unsaturated, which means it has double bond. So we also have your heterocyclic aromatic amines. The amine nitrogen is part of the aromatic ring. So this one is a heterocyclic aliphatic. No, it has no double bond to it, as you may see. So this is a ring. This is not a benzene ring, right? This is not an aryl. This is a cyclic, no? Meaning naka-cycle, nakabilog lang siya. But it doesn't mean na siya ay benzene ring or aromatic. The requisite, no, of our aromatic rings is that it should have three bonds to it, and usually or more than one double bond to it, and dapat nakacyclic siya. But in this case, there's no double bond, which means this one is an aliphatic amines. Okay, so these are the common names of this. There's no way we can memorize every name with a common name for all the benzene ring, all the cyclic, no? But instead, we'll follow the IUPAC naming, especially on the exam. I think the regular or the common naming is very important in benzene rings, and that on benzene ring you should memorize it because on the we will not be discussing carboxylic acid anymore since kulang na tayo sa time. Ang benzene ring will not um, yung mga common names sa benzene ring or the aromatics natin ay hindi na natin magagamit kasi mostly nagagamit acylic acid kasi meron yung hierarchy. But for this one, ano, we cannot memorize every amines, no, ng common name niya kasi wala naman tayong pure table niyan, especially in the book. So, I think we would rely on naming for our amines on your IUPAC naming. So, for this one, maybe kung ano lang naka-indicate dito sa book, we have pyrrolidine and we have piperidine. No? This one are aliphatics because they don't have double bonds in their cyclic ring. Okay? This one is a heterocyclic aromatic amines because it has double bond to it. So we have pyridine, pyrimidine. If you can remember this one, pyridine and pyrimidine, as well as the purines, these are very important in your nucleic acid because it is a component of your DNA and RNA. We also have your imidazole, which is a component naman ng mga medicines, no, na ini-intake natin at times, no. We also have your IUPAC naming. So we will focus more on nomenclature of your IUPAC names. So in naming, no, we derive a IUPAC name of the aliphatic. So when you see aliphatic again, these are the alkane, alkene, and alkyne. So we'll focus on alkane. Say for example, single bonded lang siya. So we have to drop the E ng alkanes natin. Say for example, on this one, this is a free carbon atom which is 1, 2, and 3. No? So this is propane, right? If we do not have any amines at the top. This is propane. So for propane, we drop the E as at the suffix of the propane and then add amine. So, and then we'll number to which carbon our nitrogen is attached. So that will be to propanamine. Okay? Kasi we drop the letter E instead, we replace it with an amine. Okay? Next, we have a cyclic. No, this is a six carbon what do you call this? Six carbon heterocyclic organic compound. So we have cyclo as per naming of our cyclic compounds, and we indicate how many carbon are there in the cycle. That is six, right? So we have six carbon. That will be hex. No, if we do not have your amine right here, we'll call this cyclohexane, right? But we have an amine at the top of it, so we'll drop the letter E at the suffix of hexane. That will be cyclohexanamine. Okay? The next one is also an aliphatic without a ring. We'll just count the number of carbon. From here, it is 1, 2, 3, 4, 5, 6. We have 6 carbon. That is hexane. But the twist is we have two amino group, which is NH2 on its terminal ends, no? So that will be at the first and at the sixth carbon yung attachment niya. That will be 1,6-hexane diamine. For this one, dahil we add di, tri, tetra, pentahexa to the number of nitrogen attached to the aliphatic group or the linear group, no? We will not be dropping the letter E. Instead, we have hexane, add how many nitrogen it is, so di, and then we add your amine. Do not forget to write it the carbon numbers at to which the nitrogen is attached, to what number of carbon it is attached. So it is 1 and 6, no? Both terminal ends of this aliphatic group. Okay, so a UPAC naming nomenclature retains the common name aniline. So this is a special example because aniline is a benzene ring with an amino group attached to it. So if you see this structure, you should use this as its family name. No, I call it family name because it is at the end of every compound with this type of structure. So as I was saying, we will not be discussing carboxylic acid anymore. But this type of naming is very important in carboxylic acid. So we have aniline. This is a benzene ring with three double bonds. And on one end of each carbon, an amino group is attached. So this one is an aniline. So for this one, this is a common name. This is nitro. Okay, when we call this, and when you see NO2, this is nitro. So it is attached to an aniline group, no, which is a benzene ring with an amino group. So nitro is just a branch, no, it's just a substituent. So how would you count if you see a substituent in a benzene ring? So for this one, you'll count to which, if it's clockwise or counterclockwise, you'll count to which side would it give you a lowest number. But since it is at the middle, so if you count clockwise or if you count counterclockwise, it will still give you the same number, right? So if you're counting here, always count first to where your family group is, which is your aniline, your amino group. So if you're going to count and start right here, this is 1, 2, 3, and 4. If you count counterclockwise, this is 1, 2, 3, and 4. Okay, so the common name is para nitroaniline. So this OMP, no, I use OMP as I memorize it. So this is ortho, meta, and para. So when we say ortho, no, this is two substituent, no, consecutively attached to a benzene ring. So by that time, your nitro right here will be on the second carbon right here to where I am pointing. So you'll call it O-nitroaniline. This is common naming. This one is very important. Ortho, meta, and para. For meta, Say for example on this one, this is M-toluidine, no? We have one space, no, after the other substituent. So your nitro, your amino, and then your methyl here. No, there's a space carbon, no? Hindi siya magkakasunod. Okay, for your para, there are two carbon without an attachment, and then finally your substituent. Okay, so I remember it as OMP for me to not forget this. This is a mnemonics I create. Okay, so maybe you'll be asking for this common naming, ma'am. Why is it M-toluidine instead of M-nitroaniline? Okay, I'll discuss later, and of course, I'll send you a copy of of a hierarchy for this one. For the hierarchy, the toluidine will be at the topmost. So on the hierarchy of the list, no, the toluidine will be the family instead of the aniline. So there's a hierarchy, and on the hierarchy, toluidine comes first. So instead of using aniline as a family name, we use the toluidine. Okay. However, on this one, this amino group is not mentioned, right? So dapat na mention siya. Okay, so okay. This can be complicated. This is correct. This is toluidine because if we remove this, this is a common name, no? We cannot contest to it because it exists before the IUPAC name existed. So, um, okay. So, for this one, if we remove this one, if we remove your amino group here, and you just see a CH3 or a methyl group, this is just a benzene and a methyl group. It's called toluene. So again, maybe nakaka-confuse ito sa inyo right now, but I'll give the link to the list of hierarchy that I'm talking about. No, ito ay mga common names and how you should pronounce it whenever there's a benzene ring right to it. No, so wala din siya sa book. And I just saw one reference. I just send it to the group para magamit niyo if ever may mga naming sa exam. Ayun. So for this one, this is toluidine. Toluidine. This is correct. Okay. So for the UPAC name, it should be 3-methyl. Why 3? If we're going to count counterclockwise starting from your amino, this would be 1, 2, 3, 4, 5. It will give number 5 number to your methyl. But if we're going to count clockwise, this would be 1, 2, and 3. So between clockwise and counterclockwise, clockwise give the least number so that we should follow that numbering. So that will be 3, then your methyl group plus your aniline group. Now, so the common name of this one is M-toluidine. Okay. Okay, next. So, name unsymmetrical secondary and tertiary amine as and substituted primary amine. So, take the largest group bonded to nitrogen as the parent amine and name the smaller bonded to nitrogen and show their location on nitrogen by using prefix N. Okay, so paano kapag ganito, no, unsymmetrical daw yung kanyang label. So again, according to this IUPAC naming, we should name the unsymmetrical secondary and tertiary amine as the N substituted primary amine. So we have to take the largest group bonded to the nitrogen and siya yung magiging parent name or yung family name niya. So on this case, we have the aniline. This one no, is an aniline, right? NH, then a aryl group. Ma'am, bakit NH2 sa kabila and then dito NH lang? Is it still considered as an aniline? Yes, it's still considered as an aniline. We just remove a hydrogen group, which is yung mga hydrogen, if we can remember, sila lagi yung nag-a-adjust, no? Sila lagi yung nare-remove. And when they are removed, no, the name is still retained, no? Minsan nagkakaroon lang ng plus, but in this case, hindi siya magkakaroon ng plus, or minus, no, or any charges here because yung electron na naiwanan ng ating hydrogen will be bonded to your carbon. So in this case, this one is still N-methyl. Why N? It is linear yung sa N. Yung methyl natin is nasa linear. And then, we have the aniline. Okay, so this one is N-methyl aniline. For this one, the large group is this pentanamine, right? This is a pentane, cyclopentane, attached to a nitrogen, which is an amino group. So this is cyclopentanamine, right? And there are two more substituent here, a small group, which we will not use as a parent kasi mas malaki yung ating pentane, cyclopentane. So this one will be your methyl substituent. So this will be, hindi natin pwedeng ulit-ulitin na methyl-methyl. We'll just use dimethyl. And because dalawa siya, we use NN kasi siya ay linear or siya ay connected to our nitrogen. Okay, so this is NN-dimethyl-cyclopentanamine. Okay. Next, for the common name, okay, for most aliphatic amines, list the group bonded to nitrogen in alphabetical order in one word ending the suffix amine. So for common name, we just count the number of um, list the group bonded to nitrogen in alphabetical order and then um, in one word ending in a suffix amine. So it always end in amine. Okay, so for this one, we have propyl amine. So this one is 1, 2, 3, which is propane. Instead of ane, we drop the ane and then substitute it with il, indicating it's an alkyl. So that's propyl amine. This one is a sec because of its form. Now remember, we have sec, iso, tert, and neo in common naming, but it is not used. And even in the exam, we will not use common names, including sec, tert, and iso. But it's nice to know, ano. It's still used nowadays, especially in chemistry. No, some reagents are still labeled with sec butylamine, tert, though Neo is obsolete already, we sometimes see ISO, no? So you have to know, of course, yung sec, ISO, and third. But here in our exams, we use mostly a UPAC naming. For this one, this is just listing all the names, no, alphabetically. So we will not count di, tri, tetra, if you can remember. We do not use that, or we did not include that in alphabetical order. Instead, we use the name of the compound. So we use ethyl first and then methyl. For this one, we have two ethyl, one methyl. That means it is diethyl methyl amine. Okay. For this one, we have a cyclic hexane or cyclohexane and an amine group. So this one is a cyclohexyl amine. Okay. If we are going to use the IUPAC naming, this will be, okay, one cyclohexamine. Okay, but this one is cyclohexylamine. You just list the name of the substituent and then add amine in the end. So that's how you name it in common naming. Okay, now we have amine salts. So what are these? When four atoms or group of atoms are bonded to a nitrogen group, okay, as for example, CH3NH3 with a plus sign above, nitrogen bears a positive charge and is associated with an anion as a salt. Okay? But remember na ang salt natin, to be considered a salt, it should contain both positive and negative charge. No? That's why when you mix a strong acid and a strong base, it always resulted to a salt. No? So, for this one, again, I'll repeat this. When four atoms or group of atoms are bonded to a nitrogen atoms, as example is your nitrogen right here is bonded to a three hydrogen and one carbon. That gives it four, no, four bond, right? If you can remember, nitrogen can only bond up to three, and it will gain two electron that is unshared. But for this one, the two electron is shared, or the one electron there is combined, no? Is combined with your, hold on. The one electron is combined with your hydrogen. That's why there will be a free electron, no, circulating on the, gaining a positive charge. Okay, so why positive charge? Ma'am, why positive charge if electron that is circulating in electron cloud is negative charge? Guys, remember, nitrogen right here should contain two electron that is unshared. Now, if we remove one electron and bonded it with one hydrogen, instead of gaining more negativity, it gains positivity because nabawasan yung electron natin. We have less than one electron available at its electron cloud. So that is plus one positivity and minus one negativity. That's why we gain positive charge. Okay, do you understand that? So I hope you understand that. So name the compound is a salt of a corresponding amine. So replace the ending amine or aniline or pyridine or the like or kung ano namang common name siya by ammonium. Okay? So that's why meron tayong amine and ammonium. So for aniline, it will become anilinium. And for pyridine, it will become pyridinium or the like. And add the name of the an ion attached to it. So for this one, this is a triethyl. Why triethyl? We have three, three, triethyl group. We have ammonium because it gains positive charge due to your chloride addition, no? And then the last name it will be your anion. The anion here is your chloride. Okay? Okay. So like ammonia, the physical property of your amines, no, are low molecular weights. Amines have very sharp penetrating odor. So amoy nabubulok na isda, no, ang ating mga amines or fishy odors, no. If you've been working in your laboratory, you might smell itong fishy odor na ito. Trimethylamine, for example, is a pungent principle in the smell of the rotting fish. Two other particular pungent amines are the 1,4-butane diamine, yun yung tinatawag natin putrescine, and 1,5-pentane diamine or yung cadaverine. Okay? So, figure 16-1, ito yon. Amines are polar compounds. Why polar? Guys, as you may see, there's a lot of hydrogen bonded attached to your nitrogen. So, it can be mixed with water kasi siya ay parehas na polar, right? So both primary and secondary have NH and can form hydrogen bond with each other. So it could mean na yung primary and secondary natin can also bond to your water. While your tertiary amines have no NH bond and cannot form hydrogen bond with one another. No? Kumbaga, binabox out ng hydrogens natin yung nakadikit dun sa nitrogen ng tertiary. Kaya hindi na siya makagawa ng another nitrogen to hydrogen bond. Okay? But primary and secondary have all free nitrogen bonded na easily natin pwedeng palitan agad yung hydrogen. Okay? So, an NH or N-hydrogen bond is weaker than OH, hydrogen bond because the difference in electronegativity, tandaan, is 0.9 while on OH no, is 1.4. So, ibig sabihin, mas strong ang bond ng alcohol in comparison with your amines. Mabilis lang nating masira no, ang ating mga amines. So, we see the effect of hydrogen bonding between molecules of comparable molecular weight by comparing their boiling point and their melting point. So for this one, ethane, methanamine, and methanol. For this one, your ethane, no, ang kailangan lang niya sa boiling point is negative 88.6, nag-evaporate na siya. But as you may see, kailangan mo ng mataas na temperature for your alcohol to dissociate. So ibig sabihin, mas mabilis itong amine talaga natin na mag-evaporate, no? In comparison with your alcohol. Okay? Okay. Itong, CH3 kasi usually 'di ba ang ating mga alkanes ay gases. So that's why, at a very high, low temperature nag-evaporate agad siya kasi siya ay gas, nagmi-mix siya with others. But your amines and your alcohol mostly ay mga liquids 'yan. So that's why they needed 'no, a higher temperature for them to boil. Okay, so, additionally, all classes of amines form hydrogen bonds with water and are more soluble in water than in hydrocarbons of comparable molecular weight. Now, again, it is because yung nitrogen natin has a lot of hydrogen bonds attached to it. So, it can bond to your water easily kasi siya ay polar compound. Okay? Okay, so like ammonia, of course, amines are weak bases, no? Yung ating alcohol naman ay acidic. And aqueous solution of amines are bases. Okay, so basic. So the base dissociation constant, this will be studied on your analytical chemistry, Kb or your dissociation constant of your base. For the reaction of an amine with water has the following form. So we have illustrated for the reaction of methylamine with water to give methyl ammonium hydroxide. So pKb is defined as the negative logarithm of your Kb. Remember, every time na may P, it means negative logarithm. Parang pH, negative logarithm of your molarity of H. Ganun din dito. This is a bit complicated for inorganic organic, but this will be studied no in your analytical chem na lang. So basicity of your amines, no, basicity of your amines, aliphatic amines have about the same base strength and are slightly stronger bases than ammonia. So aromatic and heterocyclic aromatic amines are considerably weaker bases naman than aliphatic amine. So yung aromatic ay weaker bases. Of course, yung mas linear, sila yung mga stronger na bases. Okay? Okay, so given the basicities of amines, we can determine which form of an amine exists in body fluid, say blood. So remember, the pH of our blood is 7.35 to 7.45. Okay, so in a normal healthy person, as an average, 7.40 po ang ating pH ng blood. So medyo neutral na medyo acidic, no? Slightly acidic na ito since 7 ang ating neutral pH. So if an aliphatic amines is dissolved in the blood, it is present predominantly as its protonated form or conjugate acid form. So example nito is yung dopamine, no? Amine ang dopamine, no? And this is a neurotransmitter combined with your blood. Okay. So assume that the amines are, or R means alkyl, R and H2. This means a number of your carbon to carbon compound has a pKb of 3.50. Okay. So I think I will not discuss this anymore. No, medyo complicated kasi ito. Ito ay combination na ng analytical ninyo. And wala naman to din sa exam. Hindi ko siya in-include, no? So ito ay sa analytical nyo na lang. This is a dissociation constant and hindi siya kayang i-discuss ng isang slide lang. This is a long, ito yung parang isang term ito sa analytical chem, more on computation kasi siya. So, for the reactions na lang tayo ng amines, the most important chemical property is their basicity. So, amines, whether soluble or insoluble in water, react quantitatively with strong acid to form water-soluble salts. Okay. So that's it. That's it for our discussion of your amines. No, we'll not delve much dito sa ating reactions also. No, just remember that ito kahit strong or weak acid ang combine ninyo kay weak base, which is the amines, it still form no a water soluble salt. Okay, so that's it for the discussion of your amines. Please read your book for more information for this topic, and I will get the informations in your exam on your Bettelheim book. I gave you a PDF for this, so let me know if you have any question. Just message me on Facebook or on the classroom. Thank you.